So now we'll do the least frequently used algorithm for page replacement. And it's basically a counting algorithm where you count the number of times every page appears, and then you choose the one to replace with that really that doesn't have a much count for each of the for each of your numbers or your pages. Yeah. So we'll start, and we have 1 here, 1 and 2 here, 1, 2, 3 here, 1, 2, 3, 4 here. Okay. And the point to notice here is that we have literally a 0 counter for all of them at the start. We have 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So there are going to be counter when we're going to count, or when we're going to encounter the same page which is already in the memory. We're going to actually increase their count. Okay. So the next one we have 2. So that's a page hit. We have a page hit, and also we have 2. So we increment the count for 2. So we have 1 here, 2 here, 3, 4. And what we'll do is we will increment the count for 2 because 2 appeared again. 0, 0, right? And now we have 1 again, so it's also a page hit. And now we will again increase the count for 1. Sorry. We have 1 here, 1 here, 0 here, and 0 here. So in the previous algorithm we talked about the 1, 2, 3, 4. Yeah, so the previous algorithm we talked about was second chance algorithm, in that the 0 and 1 was really representing the reference bits, right? They can't be counted, or their purpose was not to count. They were telling if something is already loaded or if something is not already loaded, right? Their purpose was that. So they can't be, even when counting the same page, they won't be counted, right? But in this case, they would be. If we again encounter 2, it will become 5. Sorry, yeah. So now that we have a page that needs to be replaced, right? So now what we can do, we will choose the one that has the lowest bit. So in 3 and the 4 has the lowest bit. We will choose the one which is the top frame. Okay, we will choose the top frame, which is kind of, the breaker here. So if we have the tiebreaker where we have the 2 things and want to choose one, we will just keep the tiebreaker as the top frame here, which will be 3. So we will be replacing 3 with 5, 1 and 4. And again, I'm going to just kind of clear my bits. So we have 1 here, 0, 0. Now we have 6 here, so now 6 is also going to be 5 because this is the top frame with the least amount, with the least count, right? So least frequent means the least count. So I'm going to change my color, and I'm going to say 1 here, 2 here, 6, and 4. Okay. And then we are going to also change our bits. 1, 1, 0, 0. Now 2 comes again, so we will have a count of 2 here, 1 here, 0 here, and 0 here. Okay. Just trying to make it clean, but I just failed to do so. 2, 6, and 4. Okay. And now we are again see that 1 is already, sorry, I didn't include the page fold, so 1, 2, 3, 4. So this was a page hit, sorry. Okay. And then I replaced 3 with 5, then I replaced 5 with 6, and now this was my page hit that I didn't include it. I needed to. So 1 plus 1 is now 2. Man. 1 plus 1 is now 2 because 1 appeared again. 2 here, 0 here, and 0 here. So that's also a page hit. And I'm also going to kind of, clear this one. 1, 2, 6, and 4, right? And now for again 2, we will again increase the counter to 3, to also a page hit because it was already in the memory, 0, and then I will increase my 1, 2, 6, 4. Okay. So now again the 3 is not the memory, so we'll change it with the topmost frame, which has the least count, which is 6 here. So we'll change 3 here, 2 here, 1 here, and 4 here. Right. So 2 comes here, 3 comes here, 0, 0. Now again 7 need to replace, so judging from the situation you can tell that we're again going to change it with 7 because 7 is of course 3 is of course the lowest one. 7, 2, 1, 4. Right. And then we can also change the bits here to 2, to 3, to 0, and to 0 again. Now 6 also need to be changed, so again 7 is going to be changed here. So again we are going to write that 1, 2, 6, 4. And we have 2 here, so 3 here, 0 here, and 0 here, yeah. And now again we have 3 here, so 3 also need to be changed, and of course 6 is going to be the victim here. 1, 2, 3, 4. 1, 2, 3, 4. And the bits are going to be 2, 3, 0, 0. Finally we get some page hit. We will increase it to 4 because we have 2 and we carded 2, 2, 0, 0. And we have 1 here, 2 here, 3 here, and 4 here. Now we can also increase the count for page, so that's the whole page hit, 2, 3, 4. And we will count 2 plus 1 is 3, 4, 0, 0. And then we again have 2, so that's also a page hit, so it becomes 5, 0, 0, and 3 here for 1. And we change that 1 here, 2, 3, 4. Finally, we get to see some page hit for 3 as well. Okay, and let me go here and put that up 3. Okay, for 3 we have a page count, so we have 1 here and then 0 here. So that's also page hit. 1, 2, 3, 4. And then we can of course 6, so we will change it with the least frequently used, which is basically 6, 4. 1, 2, 3, 6, and it wasn't a page hit at all. And then we update the bits to 3, 5, 1, 0. So let's just see how many page hits we had. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, we have 9 page hits. In the second chance we had 9 page faults, but in this least frequently used algorithm we had 9 page hits. So you can see it's but it's not, that much efficient at all.